Hey everybody, this is Jared Nunn from the Solutions Architecture team.
And this is Chris Abella. I'm from the Technical Marketing Engineering team, or TME.
Today we want to spend some time talking about the underlying data structure of the ExtraHop. So you've all spent some time in the UI and have seen that we collect a lot of different metrics out of the box. The question is, what do these metrics actually look like on the back end, and what can they tell us about why we capture what we do and where we choose to put certain metrics?
Yeah, and this will also actually be super useful for those of you starting to play with a lot of the APIs, be it PyHop or the new REST API, and actually just understanding when to use certain metrics, especially with things like the trigger API, for example, as well.
So Chris, why don't you go ahead and introduce a little bit of the API playground that we have open on the screen here as well?
Yeah, absolutely. So the API playground can be accessed at /extrahop/API playground. And what this is going to let you do is actually use something that's very, very similar to PyHop, but really quickly see how what your API calls are actually generating on the back end, nicely formatted. And if you actually are familiar with PyHop, you can see there's a lot of the stat name object type, the different fields that are associated with PyHop. So this will be like, I'm looking at specifically HTTP metrics in my application. The OID would be, the OID is going to be 0, which actually is the all activity or the default application from this is the last 30 minutes until so on and so forth.
So this is just giving us an example of what the API call would actually deliver to us?
Exactly, okay. Exactly. It's a good way to test your API calls before you do things like scripting or anything like that.
So this will give us a quick shot of what some of these metrics actually return to us so we can actually see how they're stored.
Yep, absolutely.
Gotcha. So today we're going to cover basically what we call top-level metrics in ExtraHop. And those include our counts, which are things like requests, responses. We're going to cover data sets, which is basically what we use for certain timing metrics, like, say, processing time or RTT. We're also going to talk about sample sets, which is a different way of collecting timing metrics as well that focuses on a mean rather than percentiles like a data set. And then we're also going to talk about what we call TopEnd sets. So why don't we kick it off and move into a count to start?
Yeah, so I think one of the easiest counts to work with is requests and responses. And really before we actually get to that, there's 3 types of count style metrics that you're going to typically interact with. There's your standard count, which is something where you want to sum over a time period. So requests, for example, you want to know the number of requests that you had in the last 30 minutes. Well, you're going to add 30 second plus this 30 second plus this 30 second time slice all the way till your 30 minutes, right? The next style is a snapshot style metric, and this is a point in time. So for example, the total number of connections, right? I want to know how many connections I had at this given moment in time. I don't necessarily want to sum across those last 30 minutes. And the last one is going to be a max. So you want to know, for example, who had the worst processing time. You'll want to use something like a max, okay? Right now we'll just cover the basic count, the summing count. And you can actually see here for requests, right? So we can actually go into the API playground, and you can see here the fields that we've specified for this are HTTP requests and responses. And you can invoke the API. Let's see what we get. And you can actually see here, it's, again, just a simple number. Its requests are 54,000. Responses are 44,000, right?
Yep.
And
that's
we can actually see
exactly with the UI.
What we see in the API. This is the underlying data structure for those HTTP metrics.
So that's a pretty small amount of information that we need to hold for a count. I mean, it's just it's a number.
Right, exactly. And again, this is, so we're using the total stats here. So this is actually, again, summing a bunch of little 30-second slices.
Right.
But it's easy to see how it would do that, right? It's just a
but again, for
numbers.
Each point in time, we're just grabbing one number.
Exactly.
Right? Yeah.
Exactly. Cool.
So that explains a count. That's pretty straightforward. Why don't we take a look at a data set?
Yeah, so a data set is a little bit more complicated. This is going to be exhibited in a lot of the top-level timing information, as you mentioned, your processing time, your RTT. So I actually have here a couple requests that I've pre-made just for efficiency's sake. So I'll copy and paste this into here. And you can see here, we're now looking at HTTP RTT, right? And so we'll actually invoke the API. Now what we're seeing here, and this is where a data set is what we call a frequency table. And what a frequency table is it is a table that consists of all of the values that we've ever seen. So you can see here, you have a value key, in this case 0, 1, 2, 3, 4, so on and so forth. And if we actually go deep into this table, we'll start getting 235, 236, so on and so forth. And then the frequency, this is the number of times that we've seen that value. So a data set is actually can be used to build every single transaction that we've seen, right? But it's very, very large. You can see this is a very large set of data.
So would the value numbers always span from the min value that we see and the max value that we see?
That's exactly right. That's exactly right. And that's actually one of the use cases for this, right? So data sets will let you do things like calculate percentiles. So you want to know your min or your max. Great use case. And you can actually see that here. So if we look at our RTT, we can actually hover over here and see min, max, but it also let you do your median, your 50th percentile, 95th percentile, all of those. Because again, this is a lossless data set. We have every single point of data that we have.
So that gives us a ton of flexibility in what we can show for a data set.
Exactly.
So I could come up with the 67th percentile if I wanted to.
Absolutely, if you wanted to.
Gotcha.
On the other side of that, we have what we call a sample set. Now, a sample set is where we're going to be calculating your mean, your standard average, as well as your standard deviation. And so let me copy and paste that in here. And again, so notice here that we're actually doing a custom metric. And the reason for this is really important, actually. There are no top-level sample sets, and we'll get into that in a second. So invoking this, you can actually see what a sample set looks like.
And so I'm immediately struck by the fact that the data set, you had to scroll down and down and down and down. There was tons and tons of points. This looks like what we're grabbing 3 different values. That's it for a sample set?
Yep, that's it. And great point. The sample set is much more condensed, but you don't have that granularity where you know what each transaction could potentially be. What we're actually calculating here is a count. This is the total number of samples that we have, so the total number of transactions, for example. A sum, in this case it would be, excuse me, the total processing time for all of my samples summed together. Sum squared, this is actually going to be the mean squared difference, and I'm going to skip over some of the math here. Just know that these 3 things allow you to calculate the mean and the standard deviation, and we'll provide a link for you to if you want to dig into the math behind it.
So the mean would be pretty simple. That's just the sum divided by the count. Right?
Exactly,
okay.
Exactly, right? And again, that lets you understand some of what normal behavior is like without the large data set involved in a data set.
Okay, so you mentioned that there's no top-level sample sets. Does that have something to do with the fact that this sample set stores such a small amount of information and the data sets store what appears to be a huge amount of information?
It does, and that's where, so when you have a top level metric where you're only recording, like for example, all of your web traffic, you can have a really large data set representative of that. But when we drill in and look at for every single URI, looking at the RTT or the processing time, well, recording that level of granularity for every single one of those metrics would be it'd be an incredibly large amount of data.
So that data set that we saw earlier, you would have to have that data set for every one of these client IPs?
Exactly.
Which it looks like there's 201 entries on the bottom of that screen.
Exactly.
So that's an enormous amount of data.
You start having geometric growth, right? It's for every entry you're going to multiply by that same set of data.
So then we get around that by instead just calculating a sample set for each one of those client IPs, because the amount of data is minuscule compared to what it would be for our data set.
Exactly.
But I guess that means that the top level metrics are data sets because the data sets seem to give us so much more flexibility with what we can calculate.
Exactly.
Okay.
Yep.
So we store as much, we want to be as flexible as possible, but we still have to be mindful about how much data that we're actually going to collect.
Exactly. Resources aren't infinite. I wish
Correct,
they
right.
were,
Yeah.
but they're not.
Yeah.
And this is actually something, as you build custom metrics, keep this sort of thing in mind. Top-level metrics, a perfect time for a data set. As you do detail metrics, that's when you want to start using something like a sample set, right?
Gotcha.
Cool. The last thing that we're going to go over is what's known as a TopEnd set. Now, this is actually something that is ExtraHop specific. And I'll make sure that we drill in here. We're going to look at status codes in this case. So let me pull that up in the UI. And you can see here all of our different status codes. And I'm going to invoke the API. Now, a TopEnd set is what you can think of a list of keys that have a specific type and a value that has a specific type. So in this case, for status codes, you can see that the key is of a type string. So here's our key, and it has key type, string, and the string is 403, right? Then the value has a type as well, in this case a count, and then the value itself, which is 118. So what does this mean for the average user? This is saying that for 403, the status code 403, we have seen 118 of those status codes over our 30-minute time period, right? Now,
so that means I'm immediately seeing that there's a lot of data here too, like similar to a data set.
Yep.
So if you're talking about having a value and a key, does that mean you're going to need a key value pair for every status code that we have?
Absolutely.
Okay.
Absolutely.
Or at least every status code that we've seen within that time period.
Exactly.
Okay.
Exactly. And so that, again, great point. These are, again, large data sets where you're having to keep both track of what the actual type of key is, the value of the key, the type of the value, and the value itself. And all of those things can be variable. In this case, or in the ExtraHop platform, keys will typically either be strings or IP addresses or device objects that are associated with those IP addresses. And then the keys can actually be any of the data sets that we've talked about today. So it can be a count, it can be a sample set, it can be a detail set, it can also be a TopEnd set. And we'll actually get into some of those use cases in a future video in this series.
I can already see the idea of a data set of a TopEnd set being an issue, right?
Yep.
Okay.
It's a very, very large data structure, right?
Gotcha.
When you look at nesting all of that data together.
Okay, that makes sense. So, question. In this case, we have all of these status codes. At some point, do we limit the size of this list?
Absolutely, great point. So for a TopEnd set, they're going to be 1,000 entries, and that'll be every 30 seconds. But then we'll actually sum, so take for example, over the last 30 minutes, we're going to actually take each one of those 30-second slices and calculate and then take the top 100 from that to deliver the metrics here. So for example, 200s. You can actually, this is a TopEnd set, right? This is all of the clients, in this case, the IP addresses and the devices associated with them, as we mentioned. Mm-hmm. That's going to be your key. Then the value is going to be a count, in this case, representative of the number of 200s that you've seen. And because this is summed over time, this is going to be a number of TopEnd sets summed together and delivered as the top 1,000. Well, in this case, we've only seen 185, so that's okay.
Okay, so we see 185 in this instance, but what if for this status code, this looks like 200s, what if I had 3,000 devices that produce 200 status codes in that time period?
No, that's a great question. So this would actually give you the list of the top 100 or top 1,000, devices that are generating the most 200s or generating the most errors or generating the most whatever.
Okay, so we have that sort of static, barrier of 1,000 that we're viewing at any time.
Yep,
Gotcha.
That's absolutely right. So that, I think, gives kind of a basic understanding of what some of the underlying data structures are, at least from a high-level perspective, from a top-level perspective. I think we'll do another video later in this series.
Yeah,
start looking.
Part 2 will probably be delving in even deeper.
Yep.
Okay, so we talked about, the top-end sets. You can have different data structures within the top-end set. We'll still have to look at those too, right?
Yeah, looking at more of those detail-oriented metrics, right? But until then, play around. Please play with the API Playground. Get familiar with the underlying data structures. And as always, if you have any questions, feel free to reach out.
Thanks, everyone.
Thanks.